So what I'm going to be doing is briefly talking about communication theory. I'm not going to go into a great deal of detail, but there are some concepts there that I just want to share with you. So it's a very high-level overview of communication theory. And I then want to use some examples rather than talk theory or for the whole hour. I will be providing some examples of where communication can break down or has broken down in projects I've been involved in. So without further ado, let's just do the high-level overview of communication theory. So when two parties are communicating, there is at any given time a sender. So at the moment, that sender is me, and I have some ideas in my head which I encode as a message. The receiver, that's each of you, sees or hears the message, and you decode it into a construct, a set of concepts that hopefully will match those that were in my mind when I sent it. Now, of course, ideally, communication should be two-way. It isn't always. Written communication is sometimes only one way. But if there is two-way communication, then the receiver can provide feedback. So they might say, did I get that right? I presume you mean so-and-so. And so we have a feedback loop where the receiver encodes, provides feedback, the sender decodes, and that at least provides some surety that the concepts at each end of the communication chain are the same. However, that can break down, and I've used a rather humorous example here, not a realistic example, but it will give you an idea of what the sort of thing that can happen. So if the sender is a German-speaking person, and in their mind they have the idea of poison, which is what it's called in English, but of course in German that's Gift, and the receiver is an English-speaking person who does not realize that he's been given a German word, he'll say, oh yes, I know what that is. That's a present that I can open up and get some pleasure from. This, of course, could be life-threatening, but so that's just an example of one way in which communication can break down. But in fact, there's a lot of ways. So let's just explore the inputs to the decoding process, because decoding is probably the one part of the chain where most of the problems occur. So when you're decoding a message, there is the message itself. To decode the message, you need to not only know what language you're being spoken to or written to in, but you need to understand that language reasonably well. You also need some knowledge of the subject matter. So I might read something or hear something in English, but if it's about a subject I have not much knowledge of, I'm quite likely to misunderstand what is being said. Now, to some extent, also knowledge of the sender. If I know that the sender is a person whom I've met before, I know how they think, I've heard them speak, or I watched them perform some sort of activity or something, that will also give me some further insight into what they're saying. There's also context. So a message may be in the context of a discussion. There's been a conversation, and even though I'm looking at this particular message at the moment, what that person said 5 minutes ago was this, and I can use that preceding message to help decode the new message. Or even earlier messages from the same sender. So if I heard a person say something yesterday and they're now saying something to me today, then I can use my memory of that earlier message to help frame what it is they're saying. And also my relationship with the sender. This is not always relevant, but there are certain cultures where the nature of the message varies depending on the relative rank of the sender and the receiver. This is particularly an issue in aircraft crew management, where you have a junior pilot and a senior pilot, and a number of air crashes have been found. One of the causes has been found to be poor communication because of an unequal relationship. So that can become an issue. And then one other thing is expectations. If you have previously asked a question, you will be expecting an answer, and therefore your decoding of what you hear will be in terms of what you expect to hear. Mind you, that itself can provide a communication breakdown, because as they as often has been said, we hear what we expect to hear. Okay, that's the end of the theory. What I now want to do is provide you with a diagram of the typical software development project in which we have a number of roles. There's 6 of them there altogether at last count. Yes, it's still 6. And as you can see, there are all sorts of communication flows. Some of them are bidirectional, some tend to be monodirectional, although ideally all communications should be bidirectional. They should all involve feedback to be sure that the message has got across. I just want to focus on one of these for now, and use an example from a recent project I was involved in. The business specialist knew the business inside out, and they were providing information to the business analyst as to what the functional requirements might be. Now, the business analyst had come from a totally different industry, and this business analyst, it was clear, there were occasions where they were not sure what the business specialist was saying, but didn't have the courage or the personality to say, I'm sorry, I didn't understand what you meant by that. And there was an interesting example of this. I mean, they were littered throughout the functional requirements, but one particular example was the specialist talked about a code that they use to describe a particular asset that requires special treatment, and this code is 8V. And so everyone in the business knows what an 8V is, but the business specialist, when they used 8V, the business analyst wrote this down, and then in the functional requirements was a quote from the business specialist followed by, we need to record voltage. Now, it was nothing to do with voltage, and I brought this up with the business analyst, you know, privately, not in public, and said, look, no, this is not voltage, this is something else. But if I had been, as the data modeler, someone who was not very familiar with the business, I might have assumed, oh yes, voltage is required, the business analyst has said so, and I would have included a voltage data field in there. To what end, I don't know. So it could so easily have happened. That's just one small example. I want to move now to a series of examples of things that can go wrong in the operation of a system. I will return to system development further down the track, but I thought I would share some examples of things that can go wrong. Now, some of these are made up examples, others are actual examples from my experience. And this first one, the examples are made up, but this is a problem that in Australia, at least, I don't know whether other English-speaking countries have this problem, but in Australia, a lot of organizations ask you to provide your first name and last name. Now, whilst in the English-speaking world and probably other Western European countries, the family name comes last and the given names go first, in Eastern Europe, including Serbia, it's typical that the family name comes first, then followed by the given names. So Novak Djokovic would fill in this form by putting Djokovic as his first name and Novak as his last name. In fact, in Serbian, surname or family name is prezime, which literally means first name. So this could cause a data problem, as you can see. If we're sending out letters, we would send a letter to Mr. Federer and Mr. Nadal and Mr. Murray, but then we'd also send one to Mr. Novak. So that's just a typical example of where poor choice of data names, of attribute names, can lead to problems. Here's another one. This is from an actual experience of mine when I was working for a workplace safety body, and their form that you would fill in if you had been involved in an injury included injury location and injury site. These seem as if they are synonyms, but in fact one was intended to be the location within the workplace, like the rear stairs or the front door or the loading bay, and the injury site was the part of body that had been injured, left shoulder, right foot, or so on. And so again, the poor choice of legend on the form led to mismatched data. So we had a mixture of sites and body parts in one field and in the other field. Here's another example. This is a slightly different type of ambiguity. This is what I refer to as category ambiguity. This is a genuine example taken from an application that we were trying to rejig. And the categories of asset included these four: maintainable plant and equipment, security equipment, wall mount equipment. If you've got a CCTV camera, it's most likely wall mounted, it's security equipment, it's maintainable, and presumably fits into the category plant and equipment. Which of those categories do you give it? It turned out that people just picked one and hoped for the best. So that was clearly a problem. So we recommended that there needed to be a more stable, a more unambiguous set of categories. Unfortunately, the business decided to come up with a three-level category, hierarchical category or classification system with asset type at the top, asset category at the next level, and asset class below that. This actually led to quite a lot of issues because some people thought asset type was asset category and vice versa, and type, category, and class, they are synonymous. So this led to a number of instances of confusion, and the ideal way to solve this is actually to have a search facility so you can find the asset classification that most fits what you have, and then you get the three levels of the classification system provided automatically. This took a long time to sort, and I'm not sure they've even sorted it yet. Okay, another type of ambiguity. This is what I refer to as quantity ambiguity. Now, this may, to any American guests we have tonight, this may seem like a perfectly ordinary situation. Okay, I have the choice of two flights. They both cost $163. What is the issue? However, in Australia, I have logged on to a website that provides me with flight options, but nowhere does it tell me whether these are US dollars. Now, of course, you might say I could assume it's US dollars, but a lot of US websites, when you log in, they take note of your location and, in fact, either give you the option or automatically switch to Australian dollars. So I don't know whether this website has done that, and there was no way I could tell. So my recommendation to any organization that's working in multiple countries is to provide the complete currency code, AUD for Australian dollars, USD for US dollars, CAD for Canadian dollars, and so on. So needless to say, I didn't go with this website. I went elsewhere because I just couldn't be sure what the story was. Whilst I was booking that same trip, I decided to take out some travel insurance, and I said, okay, this is the date I'm going to depart. I haven't quite worked out when I'm going to return. And then I noticed that it asked me for my age. And this is a bit ambiguous. Does this mean my age at the time of taking out the insurance, or the age as at the date I depart, or the age when I return? Now, I don't know what the rules are, and of course at that time I was not of an age that made any difference to the premium. But of course, if I was to reach one of those threshold ages where the premium changes, I might take out the insurance when I was younger than that threshold age, and yet actually be older than the threshold age when I travel. So this is an example of a poorly designed website, because any insurance policy worth its salt where age is a factor should ask for date of birth. So not good. Okay, here is a real doozy of a problem. We were working for a finance house that was getting advice from various investment advisors who specialized in certain types of stocks and shares. They would provide advice as to whether these shares should be bought or held or sold. And they would then, on the basis of that, they would invest on behalf of their clients. There's one small problem. A small group of investment advisors had got the codes back to front. So they were using 5 for buy even if you must borrow, and 1 for sell even if you don't need cash. We only discovered this by virtue of the fact that we noticed a trend. We were doing a data quality analysis, and we noticed that there was a significant trend whereby there were some advisors saying 1 for a particular stock and other advisors saying 5, which didn't seem to make a lot of sense. We would occasionally have 1 and 2 together, or 1 and 3 maybe, but never 1 and 5. And we did a pairwise analysis and discovered there was this group of advisors who got it back to front. I imagine this would have actually caused the firm to invest unwisely on certain occasions. Anyway, it got resolved eventually. And a similar encoding ambiguity is actually probably more common. It's quite common for a number of, I've found in a number of databases that days of the week are represented by digits or numerals. So that immediately raises a problem. What day of the week does 2 represent? Do we start on Monday, in which case 2 represents Tuesday? Do we start on Sunday, in which case 2 represents Monday? Or is it 0 origin? Does 0 represent Monday and 1 represents Tuesday and 2 represents Wednesday? And in this day and age, there should be no excuse for using encoded data externally. By all means, have encoded data internally in the database, but it must be represented by its true meaning in any human-facing interface, be that a screen, a report, or whatever. But, whoops, I didn't mean to do that. Sorry, hang on. I will go back to the current slide. Okay. Right. I now want to change the topic slightly, and I want to talk about ambiguity in terms of what an entity actually represents. And here's a good example. I've done a number of projects for airlines, and inevitably flight is one of the entity class names that appears in the model. But what is a flight? If you look at this itinerary, you'll notice that there's a departing flight and a return flight, but the departing flight consists of 2 flights, and the return flight also consists of 2 flights. So is this 2 flights or 4 flights or even 6 flights? What is a flight? Is it a complete journey, or is it a leg of a journey? And that's not clear. Now, obviously, I can understand what this says, but it does raise the question with me, is the flight entity being used in the database under this, and is that likely to give rise to any data quality problems? And we have actually, it's a more complex problem than that. On the left of these 3 little tables, there is 3 flights from Australia to other places, and that's fairly clear. But in the middle table, we also have 3 flights, except it's really 1 flight on 3 different days. So is a flight only on one day, or is it something that exists over multiple days? Then, of course, we go across to the third table. Here we have 4 flights, or is it 2 flights? And of course, that is actually a replica of what we saw in the preceding screen. But it gets worse. Here is the departure board at a German airport. I can't remember, I think it was Hamburg. But anyway, we can see there are flights to Munich and Frankfurt. But notice they're all departing at about the same time, and they're only departing from 3 separate gates. The laws of physics say that there can only be 3 flights. There is no way you could send more than 3 aircraft away from 3 different gates within the same 5 minutes. In fact, there are actually 3 physical flights, but what we actually see, if you look along the left side of that screen, we have a number of airlines whose flights are being run on a single aircraft. It's called code sharing. So again, what is a flight? Is it an aircraft taking off at a particular time on a particular day, or is it a label used by an airline to identify a service that they can provide to passengers? And that, unless we get the definitions of our entities really precise, confusion can reign, and if you've got multiple modelers working on the problem, let alone the process modelers and everybody else, you can very easily end up with a mismatch between what one person thinks and what another person thinks. Now, this sort of entity ambiguity can exist in multiple ways, so I'll just share a lot of those with you very quickly. Transport seems to be rife with these problems. Here we have a very sketchy map of a railway station in the Sydney metropolitan area. Now, to someone from the English-speaking world, this has 8 platforms. They would be numbered from top to bottom: platform 1, platform 2, platform 3, platforms all the way down to platform 8. But there are actually only 4 physical structures. So what are they called? Well, to the civil engineers, they're also called platforms. And we have actually a confusion in English between a platform that is a place where a train comes in and a platform which is where passengers stand. Now, of course, in German, they get around that. One of them is a Gleis and the other is a Bahnsteig. And there is a clear distinction between those two things. I would rather be modeling a railway network in German than in English, to be honest. Okay, let's look at another entity name. Employee. You might think, well, yes, everybody knows what an employee is, but does it include contractors? Does it include ex-employees? Does it include employees of our customers or our suppliers or the organization itself? So presumably it does include employees of the organization, but does it include those other people? And unless we know that, there is a risk that either the processing of contractors, ex-employees, and so on and so forth will be written to based on an assumption that certain people are in or out of this entity class, i.e. table. And given that data people and process people typically don't communicate very well, there's likely to be a problem if there is it is unclear which types of people are included in this entity class. Class instance ambiguity is another subtle variation on the ambiguity of entities. The entity class name aircraft, it can actually signify one of two things. It could either be an individual aircraft with a specific registration number, or it could be a particular model of aircraft. And I found in the various airlines for which I've done work is that they're very often unclear when they have an entity called aircraft, which of those it actually means. Now, typically, what has tended to occur is that there's been better communication between the business and modelers, and now we tend to find table names such as equipment type, which is the second, the model of aircraft, and tail number, which is sort of airline speak for a specific aircraft. Moving along. Okay, back to the railway network. In railway networks, the term line can have any one of 3 meanings. So it can either be a corridor containing multiple tracks. So we have 2 corridors here. We have the main east-west corridor along the bottom of the screen, and we have a north corridor running north from Strathfield. So there's 2 corridors. But it could also be an individual track. As you can see, there's lots of those. There's 10 individual tracks. Or it could be one of the coloured lines on the network map, which you find at stations and on trains. And of course, there are 2 of those here, but it's not quite the same 2 as the 2 corridors. So again, line is an ambiguous term, and we actually ruled out the use of the word line in any system because of that. Okay, this is a curious one. I suspect this is more a case of sloppy online form design rather than any underlying problem, but it's still an issue. Notice the discount field, where the unit price has a $ in front of it, so we know what it is. It's $49.99, although whether that's Australian or US dollars is another issue, but discount is just 5. And I queried this and said, well, what does that actually mean? And most of the people I said, they said, it's 5%. I said, well, hang on. I said, it turns out that with some of your salespeople, they agree to knock a certain number of dollars off. So how do we know that that's not actually what's recorded there is intended to represent $5 taken off the price rather than 5%? And eventually they agreed that we would put a percent sign in there, and that resolved that ambiguity. So what we've been talking about for the last few slides is data quality. And it's interesting that data quality is often considered to be getting correct data into the system, but it's more than that. It's also correctly interpreting the data that is already in the system. So in a bit more detail, data quality lapses consist either of data capture errors, and which is not only invalid data being kept out of the database, but also ensuring that valid data gets into the database. Then data interpretation errors, but not only by users, but also by developers. I've encountered a number of occasions where developers have misinterpreted data processing requirements, and we're going to share a couple of those with you in a moment. Okay, so this is back in 2002. I was involved in a workshop, and Chris Date had just published, whom I admire greatly, and this is not meant as a criticism of him, but he'd stated that 6 in the quantity column means that supplier X supplied customer Y with 6 of product Z. Okay, fine. The consensus from the workshop was actually all that means, that 6, is either that someone thought that was the right number to enter into a data field, or that someone has written a program that puts 6 in that column for some reason. And I think we need to be clear when we're designing and using systems that although it is the intention that data represents reality, it may not do so for any number of reasons. And I'll talk in just a few moments about the difference between the data world and the real world. Okay, so this is a bit of a summary about where people infer their meaning from data: developers, data providers, and data users. And I won't dwell on this screen, that's just there for the record. What I want to now do, as I said, is talk about the difference between data and the real world. In the real world, every student has exactly 2 biological parents. As far as I know, there may be some scientific developments occurring which will make that statement untrue, but as of this stage, I don't believe that's the case. However, in the data world, some students may not know their biological father, and an orphan or adoptee may not know either biological parent. And I'm afraid the word parent disappeared there for some reason. So you'll have to just take that as written. So the issue here is, although something may be mandatory in the real world, it could very well have to be optional in the data world. So let's consider birth date. Again, in the real world, every person has a birth date. But in the data world, there could be any number of reasons why the birth date is not included. The enterprise may not find it important. It may be left up to the person themselves whether they put their birth date in, and some people choose not to. On Facebook, you don't have to put your birth date in. It may be that the person doesn't even know their birth date. So what this means is that each attribute actually has 3 possible cardinalities, not 2. Attributes that are mandatory in data, like family name, for example. Attributes that are mandatory in the real world but optional in data, such as birth date. Or attributes that are optional in the real world, such as middle initial. And that's also true of relationships. And by the way, when I say relationships, I mean relationship ends, because each end can have any one of 3 possible cardinalities. Again, mandatory in data, there must be one, not only in the real world, but in the data world. Mandatory in the real world, but optional in data. So that's the one I was referring to 2 slides ago. That may be omitted if the student does not know their parents or one of their parents. Optional in the real world. Okay. In this case, the real world, it may not even exist in the real world, and therefore it can't possibly, it can't possibly be mandatory in the data world. Now, not only are we talking here about mandatory and optional data, but also invariant and variant attributes. In the real world, a person's date of birth can't change. But in the data world, it may have been entered incorrectly and need to be corrected. but I would make the point that an artificial identifier should never change in data. We also have an issue with variant classifications. What are the legal transitions? So if marital status is any one of those other things, it cannot transition in the real world to never married, but it could actually occur in the data world to correct invalid data. If somebody has accidentally been recorded as married when they were never married, that can be corrected. And of course, in the real world, you can't transition directly from widowed to divorce, but in the data world, a widowed person may be married, then divorced without the marriage being recorded. I now want to move on to problems. You know, we've sort of drifted towards it, but now I want to talk specifically about problems in communication between data and process modelers, and more particularly data people and developers. These are all situations that I've encountered in real life projects. And the first one I want to address is change of address. It's actually a misnomer. It is not, or should not be, updating the addresses associated with a person. What it should be is associating different addresses with a person. Now that may seem an academic argument, but it's important because, as you'll see in a moment, problems can arise. So what we do is, if necessary, we create a new address, and again, for some reason, we're dropping text here, and I don't know why this is happening. So the new addresses might have to be created and the old addresses might have to be deleted. And I'll explain why this is a problem. Student administration system. At a school, there are two students whose mother has decided, due to violence in the home, that she must escape from the home and move into a woman's refuge. So she does that, and she lets the school know what her new address is. Change of address. So what does the school do? They change her address, because that was how it was supported in the system. You just go into a person's record and change their address. How the system was designed, and this might seem like a good idea, the address was changed for both the mother and each of the students, but it was also changed for the father. So when he rang up to make a perfectly innocent inquiry about his children, the trainee person on the phone, after he'd given his name, said, is that Mr. Jones from 10 New Street? And he immediately said, aha, I know where she is now. Fortunately, the trainee was quick off the mark and immediately called the police, and disaster was averted. The important thing with address change is that you cannot assume that everybody at that same address is moving to the new address. Here on these two slides, this one and the next one, I've given a detailed script for what you must do to manage address change, depending on whether history is required or history is not required. But I'll leave those. I won't go through the details. You can look at those in your own time. Okay, different problem altogether. This is a real life problem, but rather than use Australian towns and regions, which you might not be familiar with if you're not living in Australia, I decided to recast the problem as one involving countries and cities, because you will all recognize the names of the countries and the names of the cities. So which of these two models is correct? Well, my position is that the top one is correct, because a city can only ever be in one country. Now, I'm often told Geneva is an exception, but as far as I can tell, Geneva is in Switzerland, even though some of its suburbs may be in France. So a city is nominally in one country, and borders may change. We know that borders have changed in the 20th century in Europe, but at any one time, a city is in one country. Now, if we take that situation that it can change, some modelers that I have encountered say, oh, that's therefore a many-to-many relationship, as in the bottom, but that is wrong, and I'll show you why it's wrong. Okay, what you in fact have is a time-variant one-to-many relationship, and the difference is important. because let's look at the user interface. And this, bear in mind, this actually happened. So I'm taking you through what actually happened, but it was regions and towns rather than countries and towns. Okay, so here is what the model should look like. And we can say that Sydney is in Australia. We select the country from the drop down and everything's fine. And if it should change, if Sydney should all of a sudden become part of New Zealand because New Zealand invades, well, then, okay, we can change it. But this does not work if there's a many-to-many relationship in city and town. And bear in mind that this system was built using Hibernate. So even though the data model had specified a time variant one-to-many relationship, the developers had decided they knew better and turned it into a many-to-many relationship, which meant that that screen would no longer be generated. What was generated instead was this: the country at the top, and then you would have a list of cities underneath, and you had a button which enabled you to add and remove cities, either add cities to a country or remove them from the country. And it worked until after a while things started to go wrong. Now, I've used a more recent example of border change here. Whatever the legality of it, there are some Ukrainian cities that are now considered, by the Russians anyway, to be part of Russia. So let's use those as an example rather than Australian cities. So what can go wrong? Notice on the left-hand side, you've got Russia. On the right-hand side, you've got Ukraine. Sevastopol appears in both Russia and Ukraine. How could that possibly happen? The problem was, I'll go back to the preceding slide, the problem was that the code had not been written to only allow the addition of a city to one country if it wasn't already in another country. So the ideal fix would, of course, be to simply add change recording or history recording to the ideal screen at the top. But if you're stuck with this screen, as in fact this organization was, we had to make the change to only allow unallocated cities to be added. In other words, you couldn't add a city to a country if it was already part of another country. And of course, the important thing is the actual date of transfer needs to be added so that you can do time-based reporting. Now, of course, what happened, this organization, over time, certain cities ended up in more than one region, as it was, but country in this example. And so we got double reporting. The numbers stopped adding up. So the underlying reason was that a lack of communication between the conceptual data modeler, the logical data modeler, and the developers. And this is the reason for this problem. So I just want to quickly share with you the way I choose to model time variance. In the conceptual data model, I only ever mark things as being time variant, but I show only relationships as at a given point in time. The extra structures required for managing time variance or recording history, I include only in the logical data model, and I would recommend that approach. That means that the business can see a model that makes sense to them, and the developers see a model that makes sense to them. I want to change subject completely now. Talk about data-driven rules. This is another example of communication breakdown in a development project. This particular enterprise originally had a fairly static way of breaking down the jurisdictions in the countries that they were dealing with. And so there were local government areas, states, counties, townships, municipalities, regions, and so on. And they had this static model. But over time, this became not fit for purpose, and they decided it would be necessary to generalize so that they could expand into other countries. And so they came up with the concept of jurisdiction. So jurisdiction could include countries, regions, cities, local government areas, states, whatever. And the jurisdiction type would be either this jurisdiction is a country, or it's a state, or it's a region, or whatever. But that then could provide us with a data quality problem, because it would be nothing to stop someone saying that the country New Zealand is located in the country Australia, or the country Germany is located in the country Finland. There'd be nothing to stop that. And so the jurisdiction type had a rule associated with it which said which jurisdiction types could exist inside other jurisdiction types. And we solved the problem. This, we said, okay, we will only allow states to be in countries, regions to be in countries, local government areas to be in states. And we designed this, everything looked great, but when the system went into operation, all of a sudden people found that they could put anything they liked inside anything else. And this was because of one simple problem. Nobody told the developers that the rules for which jurisdictions were allowed inside other jurisdictions were driven by this relationship on the bottom right, be allowed to be located in. And so the developers did not bother to enforce that rule. And so data-driven rules must always be shared with the developers or the process modelers, if that is what is happening before development occurs. Okay, we're coming close to the end now. This is one final thing I want to share with you, and that is that if you're a data modeler, you're very often required to provide a data model to business stakeholders. And I have so often seen data models given to business stakeholders who, again, to save face, will not admit that they're not sure what the notation means. So I would recommend that if ever you provide a data model to anybody, whatever it is, when you provide a data model, provide examples of what the notation means. So this diagramming notation is a separate page that gives an example of what the symbols mean. Now, you may need to walk people through it, but what this does is shows each type of relationship and what those symbols actually mean. And I found that most people can relate to that fairly quickly. And similarly, you may have a different subtype notation, but this particular subtype notation, there's the diagrammatic representation, and there are the statements of what that subtyping actually means. Okay, in the time available, I've only scratched the surface. There are many more ways in which communication can break down, but what I would leave you with is this summary. Ambiguity is a no-no. Avoid ambiguity. Importantly, ambiguous entity or attribute names are always a problem. You need to therefore you need to define your data model artifacts, be they entities or attributes, in terms of a number of things, depending on whether entity classes. In particular, quantify attributes, you must have types and units. Encoded data should always be displayed in decoded forms, and make sure that you communicate with developers and provide legends for your data models. Okay, if you're interested in learning more about some of these issues, I can recommend this book, which I recently produced under the aegis of Steve Hoberman at Technics Publications. And I'm also happy to take questions now in the remaining time, but conscious that there may be more questions than there's time available. There's my LinkedIn page URL and also my email address. So if you do have questions that you don't get time to ask tonight, then feel free to contact me, and I will endeavour to answer those questions.